So let's get into the types of distributions. There's lots of types of distributions. We're going to go over the four major types, and we usually use these as a starting point to describe and communicate what we're seeing. We could get really technical, but often it's better to stay a little bit simple in the sense and stick to the major categories and then describe the deviations from those categories. Okay, so we have uniform distribution. This is where each value is equally likely to occur. So this is our histogram plot. So this is our bin, and we're counting the number of times that our data occurs in that bin. Okay, and we can see roughly it was equally likely to occur. And really what that means is that we'll be able to, we have values that are occurring roughly about the same. It doesn't have to be exact, right? But again, rough. It's a good starting point for any type of flat distribution, be the uniform distribution. You can see our Python friends here. Please remember this. They're all wearing the uniforms. They're all exactly the same. They're all equally likely. They're all roughly the same. So that's the same thing. Every bin here is again equally likely to occur. We have our normal distribution here with the sides, and really the key feature is that it's symmetrical on both sides. We don't see a skew in a standard sense. We have our normal distributions, the bell shape that you probably have heard about in school before, and so much of natural science revolves around normal distributions. Finance can be approximated in a lot of ways with normal distributions. It's a really common thing. And as we'll get to in hacker statistics, there's some quirks in math that actually cause this in the resampling process as well. So fundamental, really important distribution to understand and get your head around. And really the idea here is that we have symmetrical, and we would usually describe this as, oh, it has a tail or it has outliers on the right-hand side, where it's kind of skewed to the left. It's a little bit more kurtosis, and that it's a little bit more skinny, or we could say it's even less kurtosis and a little bit flat, right? So we can describe these distributions many ways, but normal distribution is a really good starting point. Never really find the perfect normal distribution in your data, but you can find semi-normal, close to normal distributions. You can see our Python here, another Python friend here, our symmetrical Python friend here, and it's equal on both sides. Not perfect, but that doesn't really often occur in real life, but it is symmetrical, more or less symmetrical on both sides, and that's our normal distribution Python.